Here's how I recorded the absorbance spectrum of, in this case, the anther of a yellow Asiatic lily, the pigment extracted from that by isopropyl alcohol or 2-propanol. As you can see, the Logger Pro is loaded, and I have simply had to plug in this case, the Red Tide USB650 spectrophotometer into it, and this file comes up. We're going to measure the wavelength in nanometers of the absorbance against the relative absorbance and plot it on this graph. The first thing, of course, we would do is calibrate. The calibration itself takes about a minute. You first of all have to go up here and click on Experiment and click on Calibrate the spectrometer, and you will wait 90 seconds for the lamp to warm up. We're going to skip that 90-second warm-up because we've already warmed up the lamp. We're going to place the blank cuvette in the device, and remember, this is the solvent that we are using for the extraction. So we have pure isopropyl alcohol in the device. We will finish the calibration. It goes through all of that. And what we're trying to do here is assure that with the pure solvent there is no absorbance, which is the way it ought to be. Let's double check that now by running an absorbance spectrum on the blank, on the pure isopropyl alcohol. We'll click on Collect, and you can see it's running through the wavelengths that are available, and you can see the absorbances within the plus or minus of the instrument are all 0. We can magnify this by clicking on the auto scale, and you can see that exactly what I said, that as we go through this, the 0 absorbance is there, and it doesn't even get up in most cases to 0.005 on the relative scale. And we can double check that by running the stats on this, and we can see that the mean is 0.00054777, standard deviation 0.001237. So we are at an absorbance of 0 for all practical purposes. Alright, now we're going to shut this down by pressing Collect. First of all, we're going to go to a new, and we're not going to save our changes. So we're going to start off with a brand new sample. We're going to pull out the distilled isopropyl alcohol, and we're going to put in our extracted pigment dissolved in isopropyl alcohol. We're very careful to make sure that the clear side is opposite the lamp. We're going to push Collect here, and as you can see, after a few seconds we have a full spectrum. We're going to stop the collection at this point and go back to auto scale the graph. And you'll notice that this Red Tide has gone from about 350 nanometers all the way up to not quite 800 nanometers, and we've got a nice little peak here and here. What we can now do is find out what is that peak wavelength for the absorbance in both areas. And if we paint out this area here where the first peak is, we can run statistics on that. Click on Analyze and Statistics, and it gives us the statistics here. Our maximum is 396 in the violet range. 396 nanometers is the maximum absorbance. Now we're going to do the same thing here in the green-yellow range where we have another peak. We paint out that series of wavelengths. We click on Analyze Statistics, and here we have a maximum at 543 nanometers in the green range. This characterizes this particular pigment in isopropyl alcohol. We also did that with the water and the isopropyl alcohol in the SpectraVision or SpectraViz vernier instrument, and got similar readings in terms of the maximums here in the anther. When we have done all of this, we can then click on Dataset Options and change this so that we have a title on it, and we can call this then anther extract in 2-propanol, and down here I will use using Red Tide USB650 spec. And it tells us what instrument we used, and then of course we will file this and save it as anther pigment USB650 in 2-propanol. And that completes this particular run.